Good morning, everyone. This is Dr. GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I want to discuss about SN curve. So, generally, the SN curve is used to calculating the fatigue strength of a component. In previous sessions, we have discussed about endurance limit and fatigue failure. And in this session, so we will see how to calculate the fatigue strength of the component by using this curve. So actually, the SN curve is a record is kept of the number of cycles required to produce failure at a given stress value, and the results are plotted in stress cycle curve. So I will show you the diagram. So the curve as shown in figure. So that's why the S means it indicates the stress or fatigue strength of a component, and N is number of cycles to failure. Number of cycles to failure. Whenever the specimen or component is subjected to repeated stresses, so after some few cycles the component fails. So why? Because the stress value obtained lower than the yield stress. So at which the stress value is lower than the yield point stress, at that point the component definitely fails. So that it indicates means that is the maximum limit of that particular component or particular material. Clear? That is you can say the endurance limit or fatigue strength of the material. In this SN curve, by using this SN curve, we can calculate the fatigue strength of the material and also the number of cycles to failure. If you know the fatigue strength and the number of cycles at which fails the component, you can say. So generally for brittle materials, we will take the ferrous materials, we will take 10 to the power of 7 cycles is the maximum infinite number of cycles. See, in this diagram, the SN diagram in the recorded values, so whatever you obtained the results from rotating beam fitting testing mission. So that values are plotted on a y-axis and x-axis. So on log paper. So here represented the stress values and here represented the N value. So that is number of cycles to failure. Here dotted line represents endurance limit. Endurance limit. So this is the maximum amplitude of the repeated stresses value. Clear? So here so it is obtained. It obtained by tested the specimen and the fatigue tester mission. Clear? And the failure, these all are failure points. Clear? So beyond this stage, the failure points, the component will fail. So generally here represented 10 to the power of 6 cycles. So we have to see this is for the ferrous materials. Here the curve is in a straight line. For non-ferrous materials, never becomes this curve as this straight line. Clear? So the for non-ferrous materials, the curve is like this. So never flat. Clear? So this is for non-ferrous. The SN diagram represents these values of that means stress value and number of cycles to failure on a log paper. A little concentration will show that if the stress is kept below a certain value, the material will not fail, whatever may be the number of cycles. Clear? And this stress as represented by a dotted line, that is endurance limit. Clear? So the stress is kept below a certain value of material will not fail. Clear? So it means clear here dotted line represented. This is endurance limit. At this stage, the component never fails, irrespective of number of cycles. So why? Because that is the maximum amplitude of the repeated stress. So it is defined as the maximum value of the completely reversed bending stress which a polished standard specimen can withstand. So which specimen you have tested under the bending load can withstand without failure for infinite number of cycles, usually 10 to the power of 7 cycles. So in this diagram, shown here clearly shown this it represents A represents for ferrous materials and B is non-ferrous materials. So endurance limit value you can observe for this the A curve, the endurance limit and fatigue strength and at N1 cycles here. So by using this Nesson diagram, you can calculate the particular number of cycles to failure. So at which fails the component, that value, the number of cycles you can calculate. Is it clear? So this is N1. So suppose you want to calculate number of cycles to failure between these 10 to the power 6 and 10 to the power 7, you can calculate and two by using the empirical relations. Thank you. These are the references.
Like, share and subscribe. Hit the bell icon for more updates.